So here we have a question, if A is a symmetric matrix and B and C are skew-symmetric matrices of same order, then you have to find the correct option from these four. So before, approaching the question, let me tell you the required theory part, right? What are the rules or the properties of matrices that we have to know in order to solve this question, okay? So I'll just, tabulate the properties or the theory part that you should be aware about. Okay, so now when do we call a matrix to be symmetric? Okay, so a symmetric matrix is when the transpose of the matrix is the same as itself. A transpose is A only. Okay, skew symmetric we call when the transpose of A is negative of A. Okay, then we call the matrix to be skew symmetric. Okay, apart from this, we have to know that this property, if A times B, that is the product of two matrices A and B, the transpose of this thing combined, A multiplied by B, the transpose of that whole thing is B transpose times A transpose. Okay, and the last bit that you have to know, like when you have two matrices like A minus B, and you have to take the transpose of the whole thing, this can be written as A transpose minus B transpose. Okay, so this much theory, this much these properties we should be aware about in order to approach the question. Now let's see, using this, let me number them. This is 1, 2, 3, 4. So 4 properties you have to be applying in this question. Okay. So now see, let's see this matrix here. This is one matrix. Okay. This is, so we'll try to figure out whether this is a skew symmetric or symmetric matrix. Okay. So for that, I'll try to take the transpose of that thing. Okay. So A to the power 13, B to the power 26 minus B to the power 26, A to the power 13. This whole thing, if I take transpose, is equal to, now by the property fourth one you see, A 13, B 26 transpose minus B to the power 26, A 13 transpose by property 4. Now this is equal to, now again we'll use the property number 3. So this is B to the power 26 transpose A to the power 13 transpose minus A to the power 13 transpose into B to the power 26 transpose. Okay. And one more thing, like, B to the power some number n times transpose is the same as B transpose to the power n. Okay, for any matrix B, this property also. So let's name it as fifth one. So we'll use the fifth one here. So this can be written here like B transpose to the power 26, A transpose to the power 13 minus A transpose to the power 13, B transpose to the power 26. Okay. Now the question says that A is a symmetric matrix. Okay. A be a symmetric matrix, B and C are skew symmetric. Meaning what? That means simply that A transpose is the same as A. Symmetric matrix definition from here. B and C are skew symmetric. That means the transpose of B is the same as negative of B, right? The matrix C also is skew symmetric. So C transpose is negative of C. Okay. So this B transpose I can write minus B to the power 26. A transpose is A only minus A transpose is again A times B transpose is negative B to the power 26 here. Okay. Now 26 is an even number, right? So from here you can say this thing is B to the power 26, A to the power 13 minus A to the power 13, B to the power 26, because 26 is an even number, right? So now you see the transpose of this thing I did, I am getting this thing. So when you'll see, this is nothing but when you take out negative sign common, this is a to the power 13, b to the power 26 minus b to the power 26, a to the power 13. Okay. So this thing is the same thing. A to the power 13, b26 minus b26, a13, negative of this. So now you see what is happening here. The transpose of this thing is coming out to be negative of that thing, right? That means this thing here is skew-symmetric. Is skew-symmetric. We know the definition of skew-symmetric. That means the option number A is correct, right? Option number A is correct. This is skew-symmetric, and this is, since only we have to select one choice, so we don't need to check the others even. And when you'll, find out and try to find out this one also, you'll see that AC minus A is neither symmetric nor skew-symmetric. Okay. If you want, I can, simply check this one also here only. For we saw that this thing here was coming out to be skew-symmetric. Let's try this out also. Okay. So AC minus A, if I take the transpose of this, again by the same properties, this is AC transpose minus A transpose is equal to C transpose, A transpose minus A transpose. Now A transpose is A only, C transpose is minus C. So minus C A minus A, that is minus C A plus A. Okay. So it's not like, this thing is negative of this one or as is the same as this one. There's nothing like that. So it's neither symmetric nor skew-symmetric. Okay. So we have to select option number A as the right answer for this one. We saw that this whole thing was coming out to be skew-symmetric. Okay. So this is the answer. Thank you.